Hi, in this short video I'm going to present a very simple way of counting up the number of active supporters through time, and I'll try to give a flavour as to why this might be something that's worth considering doing. What is the active file? Well, the term file refers to your CRM, the list of pre-existing customers you've got and with whom you'd like to deepen a financial relationship through direct marketing. The term active relates to the recency of the last transaction that each customer made. I've taken that to be a year, but it could be a month in the case of monthly subscribers or monthly regular givers. So the active file file size shown down here does seem to be a pretty contrived term, but if you apply it consistently from one month to another, you can get a feeling as to sort of where drift is occurring, where the file is going down, where the file normally goes up in size, and in the case of simulated data like this, where it has gone up really extraordinarily. It might be worth stopping to think about why it would be useful to analyze the active file, and that would be dependent on your organization's needs. But one idea that I had was that because the active file comprises pretty engaged people who've shown their commitment to your cause or product by making a financial transaction, you've got here a group of people who you can both reach relatively cheaply, permissions allowing, and also a group who are pretty likely to respond to your Christmas campaign or other warm campaigns. In other words, the active file is a pretty good asset for your organization, and you might want to look back in time to see what works well, what hasn't worked so well in growing that base up to your target. So with that in mind, if we're interested not just in the size of the file, but also in the health or quality of the file, you might have better ways of doing this, but I thought it might be useful to annotate the numbers of active supporters or customers by, as you can see down here on the right, frequency, recency, and money. So for example, and this is just based on transactions that I've made up, but considering the doubling of the size of the file from the end of the first quarter in 2019 over to the corresponding quarter in 2021, if we look at the composition of the file frequency, we can see that a lot of that growth is generated by single-time supporters or customers, a group which is quadrupled in size. But if we look at those sort of more loyal supporters or customers who've made a second gift or transaction, that group hasn't even quite doubled. So the implication seems to be that in this case, the growth in the file has been driven by either cross-selling or more likely by an increase in spending on cold campaigns that may not have led to the most sustainable increase in the size of the file. It simplifies the processing if we're very clear about the definitions that we're using. We're counting the number of supporters across a range of snapshot dates or reporting dates. The set of dates that you use doesn't matter, and they could be spaced out monthly, quarterly, 6 monthly, annually, and you'll still get consistent results. The only other thing I would mention is that you've got a choice as to whether to do the count on the snapshot date, which means you're counting the number of supporters at the end of that date, or what I prefer to do is to do the count on the day prior to the snapshot date, which means that what you're really doing is saying I've got 100 active supporters going into my snapshot date. So the main metric that we are counting is the number of active supporters going into a snapshot date, as mentioned, and that might be all you want to do, but to explain the change in the size of the file, it could be useful to show the activity over the preceding interval, that is, to show the number of supporters who entered the file and the number of supporters who left the file just prior to that snapshot date. So to do that, you have to define an interval, which I've done in the green lines here. As you can see, the green lines are consistent with the dotted line and do not overlap. Just to give an example of that, if we consider the snapshot date in the middle, then there are 4 different supporters, S1, S5, F7 and S9, who've entered the file in the preceding interval, and 3 different supporters who've lapsed or left the file, giving a net change of 1. So what that means is that the snapshot, so the size of the file at the snapshot date in the middle will be 1 bigger, 1 higher than the size of the file as it was at the preceding snapshot date. To find those supporters who were active going into a snapshot date, and also those supporters who lapsed just prior to that snapshot date, it's useful to add a derived column to your table of transactions. That column would be the lapse date, and looking from left to right here, for a given transaction, the 1st of June 2015, we would project that date forward by 1 year, if 1 year is how you define your active period, to give us a lapse date of 1 year later, the 1st of June 2016. And just to be clear, the lapse date is the date from which the supporter is no longer active. So having done that, we should now have 2 tables with which to do our analysis. At the top left, we've got a list of reporting dates, and I think it's useful to pair each snapshot date or reporting date with the date of the snapshot period immediately prior to that, as you can see with these lines here. And the other table is a list of transactions coming out of your CRM or your data mart with the lapse date column added to it as a separate column. Then to proceed with the analysis or the processing, it's a case of taking each reporting date in turn, looping through the table, taking each date in turn, and finding all of the transactions in this table that are prior to the reporting date. The first thing to do is to find for each supporter their latest transaction prior to or on the dotted line. So for example, for supporter 1 here, their latest transaction was here, and the grey one can be disregarded. For supporter 2, their latest transaction was on the dotted line, and in the case of supporter 4, their latest transaction prior to the dotted line was some way before, but that's still the one we need to take. And then, given a similar list of supporters shown down here, to flag those that were active at the snapshot date, the logic we can use is to say they were active if their transaction date and their lapse date straddled the dotted line. So supporter 1 is the classic example. Supporter 2 and supporter 3 are the edge cases. So where the transaction date was on the dotted line and the lapse date was after the dotted line, they should be considered active. But where the transaction date was before the dotted line and the lapse date was on the dotted line, they shouldn't be considered active. And in the case of supporter 5, their lapse date was on the actual snapshot date. What that means is that going into the snapshot date, they were considered active, but they became lapsed at some point on that snapshot date. The process for identifying the number of the supporters who have lapsed just prior to a snapshot date is almost identical to that we use to identify the active supporters. Both processes use the lapse date, and that means that our metrics for the number of active supporters and for the number of lapsed supporters will be entirely consistent. To see which of these supporters lapsed in this interval here, just prior to the snapshot date, all we have to do is to see which transactions had a lapse date within that interval. So this is one example, this is an example on the edge, and this is an example on the far edge. All of these supporters could be considered lapsed, and the other two did lapse, but supporter 13 lapsed in one of the periods following this snapshot date, and supporter 14 here probably lapsed just prior to this snapshot date. So what we've done so far is look at our list of supporters and flag whether they were active or lapsed just prior to a certain snapshot date. And it can't be the case that a supporter will be active and lapsed at the same date. So to find the size of the file, all we have to do is count the number of ones down this column. And to find the number of supporters who'd lapsed, we just count the number of ones down this column. I've tried to calculate the number of new supporters just prior to a snapshot date using similar types of techniques, but I've found that it's quite difficult to get the net increase, the number of new supporters, less the number of lapsed supporters, to match with the change in the size of the file. And the reason seems to be that there's quite a lot of edge cases that all need to be accounted for, leading to quite a lot of complex processing. What I found that works quite well is to use the same table that we've just looked at and to add 3 derived columns to it. So by example, for this supporter, we see that in this reporting date they were active and not lapsed. Then we would get the same 2 columns from the previous reporting date, so that would be the 1st of January 2015, and we see that they were active in that period and not lapsed in that period. So we can see that they were active in the previous period, active in the current period, so we can infer that they were not new in the current period. Equally for this supporter, they were active in the current period, as you can see here, but we had no information on them in the previous period. We didn't see them in the previous period, so we can infer that they were new in the current period. If you've made it this far, congratulations and thank you for watching, and I hope it's been somewhat useful, and wish you luck in analysing the active file.